Hello, in this video let's discuss second question of today's biweekly contest. You are given array prices and where price of I is the price of stock in dollars on I3 and an integer k. You are allowed to make at most k transactions where each transaction can be either of the following: buy on day I, sell on later day, or sell on day I and buy back on later j. So normally only we can buy today and sell after, but in this case we can sell today and we can buy after also, and the profit will be price of j minus I if we are not it is a normal transaction, else price of I minus price of j. You must complete transaction before starting another. Additionally, you can't buy or sell or same day. Return the maximum total profit you can make by at most k transactions, and constraints are length is up to 1 in 3 and k is obviously less than or equal to half of the length and price is up to 1 in 9. So n and k are less than or equal to 1000. Let's think at a present index. For example, at present day, what can we do? We can do nothing because no need to sell or no need to buy. So this is a possible state, this is a possible case, and we can buy now if we sold any of the previous days, because it is given that if we buy now, we must sell it before buying again. So here at the present day we can do nothing, or now if we are trying to buy, when we can buy? Only we can buy when we already sold in any of the past days. So we can buy now if sold any of the before days, and we can sell now. And when can we sell now? If we have bought in any of the previous days. So if we bought in any of the previous days, then we can sell. And we can buy if we sold any of the previous days. So these three are the possible cases. And because it is given that we can have at most one in any hand at any time. So let's assume we have variable indicating whether we bought or sold till today. Because how can we know that we bought or sold till index I? So obviously we have to have a parameter saying that if it is 0, it is something, if it is 1, it is selling, something like that. So what is the function value? Let's assume function of ik status. I is the present index because we want from which index the answer, and k represents what is the number of transactions remaining, and status, let's discuss now. So this function of ik status returns what is the answer for array from index I, and we can do at most k transactions because at most k are left, and we are returning the maximum value. And what is status? So status is equal to 0. It means that it is we did not buy or did not sell before indexing. So we did not buy anything or we did not sell anything till before I. And if status is equal to 1, it means that we bought already. So if it is 1, we bought already, and at present index, then we can sell. And similarly, status is equal to 2, we sold already and waiting to buy at present index. So this indicates the status variable. What is that indicates? And let's simulate some cases at present index. What are the possibilities? So we can do nothing. So simply answer is equal to max of answer and function of I plus 1 ks, because we want from the next index, because this is the array, and at index A we are going to do nothing. So return from the next index. So it is I plus 1. So simply f of I plus 1 ks, because we did not do any transaction, so k did not reduce, and state is exactly the original, because if we buy anything and we are not doing anything now, so simply buy will propagate it forward. And similarly, we sold before and we are not doing anything, so obviously sold will be propagated after. So simply status will remain same and k will remain same, I will be incremented. And if s is equal to 0, it means that we did not buy anything or we did not buy sell anything before the present index. It means that we bought, we may have complete transaction, but after the transaction there is nothing in the present hand. So we did not buy anything after before transaction, or we did not sell anything after before transaction. So if s is equal to 0, then there is nothing, so we can try to buy now. And if we are buying now, what will be the status for rest array? For example, this is the array, and at present index we are buying. So we discussed that status is equal to 1 if we are buying. So at present index we are buying. For the rest of the array, we have to say that we bought a value now. So it will be 1. So function of I plus 1, k and 1. Because 1 why? Because we are buying here. And minus v, because we are buying and we are giving the money. We are giving the money and taking the product. So minus v. So answer is equal to max of function of I plus 1 k1 minus v. Because 1 is to say that we bought, because we are having a transaction to sell. So this is 1. And minus v because we bought the present value. And similarly, we can sell also. So function of I plus 1 k2 plus v, because we sold the 1, so we got the value, so it is plus v. So these are the two cases possible when s is equal to 0. And why there is no -1? Because we bought or sold. But why there is no k-1 and simply k? Because we have not complete transaction. Because we bought or sold. But in the later days we will sell or buy. For example, we bought here and the transaction will be completed when we sell this one. So only when we are selling, then k will be -1. And similarly, if we sold now, when we are buying, then transaction will be completed. So we have to reduce k when the transaction is completed, but not when we are beginning now. And else, if k is greater than or equal to 1, it means that s is equal to 1 or 2. And if k is equal to greater than or equal to 1, it means that we can do one transaction. So if s is equal to 1, it means that we bought a value before already, and now we are trying to sell. Now if we sell, what is the value? We are selling, so we are getting the value, so plus v. And now we complete a transaction because we bought earlier, because it is 1, we bought earlier, and at the present time we have sold the old one. So k-1 because we complete transaction. And what is the status for the rest of the array? It is 0 because we bought and we sold already. So we did not buy or we did not sell. So it is simply 0. So answer is equal to function of I plus 1, k-1 and 0. Plus v because we sold. And similarly, if it s is equal to 2, I plus 1, k-1, 0, minus v because we are buying the product. Hope you understand why we got k-1 here and not k here, because we just started a transaction here. We bought or sold only. But here we are trying to complete a before transaction which was bought or sold. So only now the transaction is completed and we have reduced here. And finally, if we try to create some tree for recursion, we will observe that there are many recurring subproblems. So simply memorize it. And what will be the memorization vector? It will be simply dp of IKS, because you have to store IKS as well. So if it is computed already, return the value, else find the value. Let's check the code for more clarity. So this is the value, this is the main function. We are mem setting the dp with -1, so we are filling all with -1. So if the value is -1, it is not computed now, so compute now. If it is not -1, it means that we already found this value, so simply return this. And we are making a global vector and returning f of 0 comma k comma 0. So starting from index 0, we have k transactions to do and status is 0 because initially we did not buy or sell anything. And what is the function? So let's check this. If I is equal to p dot size, it means that we have reached the final index. So if s is equal to 0, so if status is nothing, then return 0, else just m value. And now if dp of IKS not equal to -1, sorry, what is m? I did not discuss before. So let's say we did not, for example, we did not complete transaction. For example, in the last index, we bought a value, but after I is equal to p dot size, so after completing the array, we still have one transaction left. So that is not possible. So now return the least value, which is -114, because after the completing array, we have to complete transaction. We should not have anything in our hand. So if s is equal to 0, it means that state is completed. So return 0. If state is equal to not 0, it means that we have to sell or buy, but there are no values to do that. So return the least value, which is -14 or minus any least value. Return increment. And if the value is not equal to -1, it is already computed. So return that value. And v is equal to p of I, so the present value, and answer is m. Just that is the least value. Anyways, it will be updated. Answer is equal to max of this one when we are going to do nothing at the present index. If s is equal to 0, we discussed before, and k greater equal to 1, we discussed. And similarly, before returning, store the answer in the dp. In this way, we can find the answer. If you have any doubts, comment below. See you in the next video.